Hello everybody, and welcome to another geometry video. In this video we'll be talking about section 9.6, angles of elevation and depression. The learning objective for today is that students will be able to accurately draw and label diagrams for situations that include angle of elevation or depression. Students will be able to use the correct trigonometric functions to solve for missing values. We have a short agenda for this video. Number one, we're going to talk about what are angles of elevation and depression, and we'll label some diagrams with those. And then number two, we're going to do two examples together that use this concept. All right, let's get started for today. All right, so we're in our 9.6 notes section, angles of elevation and depression, and this should be page 6 in your packet. Angles of elevation and depression are always measured from a horizontal line, and let's talk through the 4 different locations in this diagram and see if we can understand angles of depression and angles of elevation. All right, so let's start with angle number 1. So angle number 1 is this angle right here, and we're going to use a little bit of logic for this problem, but we have a bird up here, and the bird is looking down at this person. And so that's why we're using the word depression here, is because that indicates something that's looking down or towards the ground. And so this bird has an angle of angle number 1 is the angle of depression from the bird to the person in the balloon. So from the bird to the person is a angle that's going down. It's an angle of depression. All right. So we're going to use this same idea to fill in these blanks. Angle number 2 is over here. So for angle number 2, this represents this person looking up at the bird. So we're talking about this angle right here, and this is the person looking up at the bird. All right, so what we're going to fill in the blanks with is this is the angle of elevation from the person to the bird. All right, and you'll notice that the first 2 angles are kind of just the same information but flipped around. So angle 2 is the same as angle 1, but it's the angle of elevation instead of the angle of depression, and it's from the person to the bird instead of the bird to the person. Okay. All right, let's continue. Angle 3, so angle 3 is right here. And so what does this represent? This represents this person looking down at the bottom of this mountain. Okay, so this is this angle right here. It's this person looking down at the bottom of this mountain. So we've got angle 3, and let's fill in the blanks here. Angle 3 is the angle of depression from the person to the bottom of the mountain. Okay, so this is the angle of depression from the person to the bottom of the mountain. All right, and then lastly, we have angle 4 here, and this is the angle of elevation, because it's going up in that direction, from the bottom of the mountain to the person. So to fill in our blank here, this is the angle of elevation from the bottom of the mountain to the person. All right, so that's the idea of angles of elevation and angles of depression. As we work on our 2 examples, you'll notice that the context is really important for deciding these. And so let's try our 2 examples. All right, first example. While flying a kite, Henry lets out 30 feet of string and anchors it to the ground. He determines that the angle of elevation of the kite is 58 degrees. How high is the kite above the ground? All right, so I would like us to draw a picture for this scenario, and I'm not going to worry too much about if it's perfectly to scale or not. I'm just going to make sure that I have a triangle set up for this problem, and then I'm going to try to label it accurately. All right, so let's read the problem again. While flying a kite, so we have a kite up here. It's a very rough sketch of a kite. Henry lets out 30 feet of string and anchors it to the ground. So this distance right here is going to be 30 feet in this problem. Okay, that's the string from the ground. He anchors it to the ground here. It goes all the way up here in the sky to the kite. We also know that the angle of elevation in this problem, so the angle of elevation is from the bottom moving up to the top here, is 58 degrees. Okay, now my picture is not perfectly to scale here, but we still have enough information to solve this problem. And we're trying to figure out how high is the kite above the ground. So we're trying to find this value here. This is the height of the kite above the ground. This would be the distance along the ground that the kite is going. And so we're trying to find this value here, the height above the ground. All right, so now we need to think about our SOHCAHTOA, sine, cosine, and tangent. We're looking at this angle here. So this side is the hypotenuse. It's the longest side. And this side is the opposite side. So I've got the opposite side and I've got the hypotenuse. And so when I'm setting up my trigonometric function, I should use the SO part of SOHCAHTOA. And I'm going to use sine to solve this problem. So let's set up our equation here. So we've got sine of 58 degrees. Sine of 58 degrees equals x over 30. And remember, when we use sine, this is the opposite side and this is the hypotenuse. So our fraction works out well here. Now to solve for x, we're going to multiply both sides by 30. Let's write in that step here, times 30 times 30. And we're going to plug this into our calculator. So we get 30 sine of 58 degrees. 58 degrees equals x. Let's plug that into our calculator and see what value we get. It should be less than 30 because 30 is the hypotenuse. 30 sine of 58, and I get a value of 25.4 degrees rounded. Sorry, 25.4 feet is the height above the ground. 25.4 feet for this problem. Okay, so this distance right here is 25.4. All right, moving on to the next example. Mayreen is standing on top of a school 100 feet up. If she looks down at an angle of depression of 65 degrees, she sees Raina. How far from the base of the school is Raina standing? All right, so I'm going to draw a rectangle to represent the school. So here's the school in this problem. Okay. And then we have a person at the very top looking down at another person. And so we have a situation that kind of looks like this. Here's a person at the very top. Okay, they're looking down. And let's label this a little bit better here. We need a horizontal line from this person. So they're looking down at an angle of depression of 65 degrees. So remember, angle of depression means that they're looking down from the horizontal line. So this angle is 65 degrees. And then we've got this other person down here that they're looking at. And what we want to find out is how far from the base of the school is Raina standing. So we're trying to find this value. We know that the school is 100 feet tall. So I'm going to label this as 100 feet. And now we have our situation set up here. So we've got an angle of depression of 65 degrees. The school is 100 feet tall. We're trying to find this distance. And we need to know one more important thing. So if we think back to alternate interior angles and complementary angles, we can solve this problem in two different ways. So the first way is that we know that this is a right angle here. And we know that this up here makes a right angle. So what we could do is just subtract from 90, and if this is 65, then we know that this angle has to be 35 to make a perfect 90-degree angle up here. So that's one way that we can start to find some angles. Another way you can solve this problem is that we know that this line is parallel to this line, which means that this angle is the same as this angle up here. These are alternate interior angles, and this would be 65 degrees. So we have two strategies to find angles in this problem, and it doesn't matter which angle you choose to use as long as you select the correct trigonometric function for this. Okay, so I'm going to go ahead and use this 65-degree angle. That was the angle in the problem, but you can use the 35-degree angle if you'd like, and I'm going to set up my trigonometric function. So I realize that from the 65-degree angle, this is the opposite side, and this is the adjacent side. And so I'm going to use tangent, or the TOA part, of SOHCAHTOA. All right, so here's my formula. So tangent of 65 degrees equals the opposite side over the adjacent side. So I get 100 over x. So this is my opposite, this is my adjacent. Okay. All right, now I need to solve for x here. And if we multiply by x and divide by tangent of 65, that results in these two values being switched in our equation. And so I'm going to end up solving this. X equals 100 over tangent of 65 degrees. And that's what I can plug into my calculator. And if you set this problem up a slightly different way, you should still get the same final answer. You can do this with setting it up from the 35 degrees. It would be x over 100 instead. All right, let's plug this into our calculator. 100 divided by tangent of 65 degrees, and I get a value of 46.6 feet in this problem. 46.6 feet, and that's the distance that Raina is standing away from the school. All right, that concludes this video. Thank you very much for watching.